Here I'm asked to solve for the variables in each triangle below. So for the first one here, I am looking for the angle theta here. Given 15 and 20, using SOHCAHTOA, I know that I have the adjacent side here and the hypotenuse, so I'm going to say that the cosine of theta is equal to the adjacent side over the hypotenuse. I gotta solve for theta here, and since I'm looking for the angle, I know I'm gonna need the inverse of cosine. So what that means is I wanna get rid of this here, and the only way to do that is to take the inverse of cosine on each side. So really I got the angle equals the inverse cosine of 15 over 20. Now, if you had a no calc test on this, you could just leave your answer as so, and then in this situation, I have a calculator here that I'm going to go ahead and use. So I'm going to go ahead and plug this into a calculator. A reminder on how is that you should see, let me get this cleared here. You should see here on the second option where it says cosine, I'm going to hit the second button, cosine. That gives me the inverse. Then I plug in 15 over 20, and that gives me my answer in whatever decimal this is, which again we don't want a decimal here because we know that this angle is going to be more than 1 degree. So if we go to mode really quick, we want to go down and change that to degree, hit enter, and let's try that again. So cosine, inverse cosine of 15 over 20 gives us about 41.4 degrees. So let's get back to here. We got this is equal to 41.4 degrees. Second one here, we're also going to be looking for an angle. The only difference here is that I have the opposite side. So I'm going to use sine of the angle equals the opposite side over the hypotenuse. I bring back my calculator. I hit, hopefully working on this, I have the second option again. So I get the inverse of cosine. Sorry, the inverse of sine of 3 over 10. And that gives me about 17.5 degrees. So again, I used the inverse of sine to get rid of this stuff. Sine -1 of 3 over 10. What did I say this was? 17.5. So 17.5 degrees for number 2. Now this next one here, I have x on the outside, and I actually don't really need a calculator for this one because this is a special triangle. If I have two sides that are the same on a right triangle, I know it's a 45, 45, 90. And so that tells me that these sides here are just equal to the hypotenuse times root 2. So I got 5 root 2 on this one. And on this one here, I have a 30, 60, 90, so I don't really need a calculator for this one either. So what that means is that I know 30, 60, 90, that the short side is half of the hypotenuse, so x equals 4. And then y is whatever this angle here is times root 3, so y equals 4 root 3. And again, that's just knowledge from my special triangles.